Hello, I'm a grade 2 student in Peking University, and let me introduce my Mahjong AI 国士无双. 国士无双 is a Chinese standard Mahjong AI focused on the tile efficiency. On the tile efficiency, 国士无双 uses two different algorithms separately for hand tiles with big or small shanton. 国士无双 also tried to consider defense, but it failed to achieve a good effect. Tile efficiency is a process of hand development where a player seeks to maximize the use of either draws and discards to attain or even complete the hand as fast as possible. In the tile efficiency, we pay little attention to other players' behaviors. It is just like a single-player game. For convenience, just the algorithms for discarding are introduced below. That is, which tile should the player chooses to discard in his own round. The algorithm for deciding whether pawn 杠吃 is approximately. Shanton is the number of tiles needed for reaching tin pai. In other words, a player needs at least Shanton 加1 rounds to win without considering the limit of points. In Chinese standard Mahjong, winning tiles must have points greater than 8. When Shanton is small, we will have enough time to search out all possible situations to win in the least rounds. Otherwise, there exists two greedy algorithms. First is the search algorithm. For convenience, we simplify the game as a single-player game with only drawing and discarding. In each round, the only player draws a tile from all the living tiles with uniform random and chooses one of his tiles to discard. Define PSL as the maximum probability that the player with tile set S can win in just L rounds. Here S is a multi-set. Suppose the least round we need to win is L, then we just discard the tile T with maximum P S minus T L. Define win S equal 1 when the player with tile set S has 1, and win S equals 0 otherwise. We have the following expression to calculate PSL. There T are all living tiles. We get all tiles with equal probability. And here PSL equals to, when L is 0, it equals to when the player has 1, it equals to 1, otherwise it equals to 0. When L greater than 0, it equals to this. That is, we choose a tile T to play with a maxed P. Because we need to calculate the points and other things, so it is slow. So some optimizations are used in my implementation to make it faster. Okay, let me introduce the fast greedy algorithm. When When Shannon is big, we need to use greedy algorithm rather than the search algorithm. Enumerate the tile to discard and use dynamic programming to calculate the minimum number of rounds to win and the probability of the leaving tiles approximately. For convenience, we simplify the game as a single-player game, same as before, and only consider the winning form of 4 males and 1 pair. The dynamic programming includes 2 parts. First, calculate the minimum round to get I males and J pairs, and the probability approximately for dot, bamboo, character, and honor separately. Second, merge the output of the first. The part 1. This problem is trivial for honor and same for dot, bamboo, and character, so we only consider the approach for dot. Define min round this as the min round to get male count males and pair count pairs using dot 1, 2, 3 to the I and ce dot I minus 1 and I left for get males for of dot 1 minus 1 I minus 1 I plus 1 in future, and C2 dot I left for get males for of dot I plus 1 I plus 2 in future. The result we want is min round 9 because we have dot 1, 2, 3 to 9. Male count, pair count 0, 0 because when I equals to 9 we can't get males in this form. The transfer is easy and we can calculate the probability approximately at the same time. The part R. Part R, we need to merge the output of the first. Think dot, bamboo, character, and honor as different items. This problem is similar to knapsack problem. Define min round I, male count, pair count as the min round to get male count males and pair count pairs using item 1, 2 to I. The result we want is min round 4, 4, 1. This 4 means we have 4 items. It is easy to transfer and calculate the probability approximately at the same time. The disadvantage of the previous algorithm is that it can't consider the limit of points during dynamic programming, because the rule of point calculating is very complicated. I observed that in most cases the number of possible final winning tiles with the least rounds for current tiles is small, so it allows us to search out all possible final winning tiles, calculate their points, and approximate contribution to the probability of each tile. This algorithm may exceed the time limit in a few cases. In this situation, we change to use the previous algorithm. Thank you.